So when I left you last time, I had gotten the HLS to build, but I could not use it because the project that was supposed to attach it to, based on that work shop, the stuff they provided there, that project was not. I couldn't change it. When I tried to change it, I couldn't synthesize it. What it was doing is complaining about a particular component, which is the MIPI CSI-RX0. This, I believe, is what takes the physical data, turns it into packets that can then be used by the rest of the system. Now, as you can see, we made some progress. I was able to synthesize. I was able to add in the edge detect. Although, so far it's not working, and I will explain why I think it's not working. I did validate a couple of things. I validated that the original program does still work, and I'm going to talk about the changes that I made to get this thing to actually synthesize. So the first problem I had to deal with was this particular module. Now, what Vivaldo was complaining about is saying you instantiated this thing, this component, but you did not, or there was a component within it. It's actually not. It's a component which is, I believe, a buffer, one of the buffer objects, and saying, well, you have this access data count and it's not mapped to anything. I looked at the code, it looked like it was. I tried mapping all kinds of stuff, not working. So then I looked at it again and said, you know, I don't think it's being used, so I'm just going to comment it out. Because it was defined, it was in fact mapped to a buffer. It was mapped to something. But nonetheless, it was still complaining. So what I did is I decided I needed to, to try to comment it out. I commented it out, and then it stopped complaining. And I'm thinking, okay, I'm not using it, so this hopefully will work. So I got it to synthesize, and then I brought in the edge detection component that we created last time. And basically what you have to do to bring in a new component, go to your IP catalog, and when you use a repository, you say add IP to repository. When you create the component in HLS, it creates a zip file, and that is what you're going to use to create this, to bring into your repository. But back to the diagram. So anyway, got to synthesize, I brought this in, and two things. First of all, the version in the information was not exactly like this, so I kind of had to kludge it a little bit. Let me see if I can get some better focus here. I am probably, this isn't, there. This is a bit of a new camera for me, so at any rate, so what I did is I kind of had to guess a little bit, but I think I got the stream in and the stream out right. The stream in goes to the output of the VDMA, which was originally hooked into the output, because they do tell you to take what's hooked up and break it and stick the the new component in between there. And you know what else I'm going to do? I'm going to run this here. What this does, it kind of makes it look a little neater and moves things around. So you can see here, I am going from here to the edge detect, and the edge detect goes to the video out. So that I think is right. I also added the constant that they recommend, which has to be, oh, I may have found an error here. Nope, it's right. I got app start and reset is hooked into the constant, and that constant is 1, so that's correct. So we have set that up. That looks correct, but I ran into another issue. The other issue I ran into was that the timing wasn't right. It was complaining that this wanted, because you have to connect it to a clock. And honestly, because things had changed, I was not clear which clock. So since I think they called a pixel clock, I said, well, we'll use this. The problem was, this thing was getting 150 megahertz, and this thing wanted 100. So I said, all right, how do we change that? Well, one thing I did is I added this one I don't really need, but I changed 2, which runs through all the things that eventually get to, or clocking, eventually get to this clocking. Let's see, so you can see this runs back here, and then this eventually runs back to, let's get that, it goes back to here. This goes back to here, and eventually, but at any rate, I changed the clocking from 150 and do it in here, 150 to 100 megahertz. Let me get to it. Here we go. And if you go to output clocks, I changed output clock 2 to 100, and it seemed to like that. So I'm like, fine. Okay. So then it all synthesized. I got the, I had to recreate the project in the SDK. And the problem I ran into it when I tried to run it is it looked like it was running, but all I got is nothing. No signal going to the HDMI. Now, like I said, I verified all the hardware, all the connections are good by using the previous project. So, and this is something that I'm going to look into, what may be going wrong. Well, first of all, there could have been something that changed in making the change I made to this component, that maybe I'm wrong. Maybe you did need that. Let me show you this, and I'll explain, because I talked about it, but I didn't. Now, in order to edit a component like this, you got to go to Edit in IP Packager, and I will show you what I did. This is this is another Vivaldo, because all these components are is VHDL or Verilog components, essentially like classes that you would use in Java or C if you're coming from that kind of background. Let me show this to you in order to do that. Okay, so here is the IP packager, which again is just another instance of Vivaldo, except they have this. This is what you do at the end. But what you can do in here is, here's your code. So I looked and I knew what was complaining. It was, let's see, where did it go? Where did it go? Nope. Do I have the right one? Oh, wrong one. So I was on the wrong module, so. Okay, close that. Okay. It's this one. Okay. So, now we're going to bring up the IP packager and have a look at this module that was giving me problems here. Like I said, it was complaining. I'll show you what it was complaining about once it comes up. But it's basically did not like one of the component instantiations. And again, it's if you think of in terms of objects, if you are used to programming in an object-oriented fashion, this will make perfect sense. And make sure I can bring this up. Alright. Okay, so back to this. So, once you have this open, you can go and you can actually look at the code. And where it was complaining was in LLP.VHD. And let's give ourselves a little bit more room. So it defines here's your entity LLP, and it defines components as part of the architecture, one of which is the line buffer. And the line buffer had this thing, access data count, that it defined on line 111. And if you go down to line, it's roughly here, this is another thing this is actually something, yeah, it doesn't like this. What it wants you to do is define another signal and as not RST and then use that. But anyway, this was defined here in this port map for line buffer FIFO. For some reason it didn't like it. Did not make sense to me. But when you look for this, which is the signal it's attaching to, mbuf data count, so actually I can just do Control F and mbuf, what's it called? mbuf data count. So you had this signal. Let's go up. Which is just same matching standard logic vector 31 down to 0. And you go next, it defined it, and then it did some stuff with the debug, but didn't really use it. However, I could be wrong. And maybe you have to have that for this item to work. At any rate, so once I did that, it stopped complaining. And I'm going to get out of here. But you can see you can look at any of the code in here. And then what you do when you're done is you repackage it. I even tried adding a separate port for it, pin. And that got interesting. That got really interesting because what ended up happening is when I tried to do it, it just threw the whole hierarchy out of whack. And I had pins that were under, if you look here, I think it is this? Ports and interfaces. So if you look in here, you've got a bunch of ports associated with AXL Lite, some port with MXS video, this is master, and then the clocks and signals. So I tried adding something, and everything got thrown out of their little groups here, their interface that they were grouped together. So I ended up and it didn't work. I was still getting the same error, so that's why I backed off and said, well, why don't I just get rid of it? So you see what I did. So I had to change something in the package, one of the packages that was provided. I had to try to kludge a little, particularly with the clock, for the edge detection module. And as a result, when I went to run it, nothing came out. So my suspicion is that it has to do with the clocking. The clocking is off, and consequently, with the clocking off, it's not going to be able to hook up to the HDMI and get our signal out. So that's kind of where I leave it. I think I'm going to try to start going on to something else next time. I'm thinking I might want to talk about PMODs, which are these little peripherals that can plug into the Digilent boards. If you look, this is the Arty board here. If you can see, let's see if I can hold this up. Right, you see these little plug-in, I don't know how well you can see that. Bring it back a little bit. But these you can actually plug things in that you can use as peripherals. You can plug in among the things you can plug in are sensors. You can plug in a little screen, things of that nature. So it's kind of like how you might hook a door, like let me see if I have an example here. Oh, this is kind of. So this is a little thing I've been working on, but you can see how you can plug in. This is a clock module and a screen into this this board here. This is the Adafruit Metro, and Arduino type boards. I guess I didn't get it high enough here, so you can see how I have. This is a clock, this is a video out into this board. You can do, the PMODs, they serve a similar type of function here. So that's, I think that's where I'm going. I am going to try to see if I can get this working, because I want to get this thing to work. If I do, then then I will definitely make a video and tell you how I got it to work. But you know, the goal is is to see if I can get that autonomous car eventually. That's something I want to make. I mean, the camera is kind of the start of the machine vision type thing, and that's just where it begins. So the other thing I might want to try is seeing if I can get some kind of video in and out without having to use the special digital modules. If I can use it with the straight modules that come, the things that come from Xilinx, use their libraries only, and we will see if that's a possibility. The other thing to look at is OpenCV. That's another thing I want to look into. I know on Paul McWhorter's channel, Mr. McWhorter is doing some excellent tutorials on the Jetson Nano, and I think I've mentioned this before. He is taking it from, I mean, he literally started at the beginning, put the thing together, giving some basic introduction to Python, the Python programming. He is a double E, I think. More of an engineer than a programmer, so that's his strength. He's very experienced with the electrical engineering aspect of things, and I know he is working towards using OpenCV to do AI stuff with this Jetson Nano. And he's premiering his videos 10 a.m. on Saturday mornings, 10 a.m. East Coast time in the U.S. So I think that's GMT plus 5 or minus 5. GMT minus 5. Except it may be a little off now because of the changing to winter time and all that business. But anyway, so that'll be all. Hopefully I've shown you something of how I tried to work around this issue and why I think it's still, while the program appears to run when I try to run it, it's not actually producing output. I think there is a timing issue that the edge detect was somehow getting things from a clock that was giving it 100 megahertz or whatever that 100 is, and now when I tried to hook it up originally, it was 150. Didn't like that, so I set it back to 100. Well, that affects other things. So that's not good. One thought I did have is just directly, fine, you need 100 megahertz. We'll just give you 100 megahertz and make it separate. But I'm not sure if it's going to like that. So at any rate, thank you for watching, and please subscribe. Please, if you like, hit a like. Comments. If you've solved this, I'd love to hear how you did, and this way we can share it with anyone watching the video. So again, thank you, and I will speak to you next time.